Hello, I'm Guy Burrows. I work at RACE, which is part of the UK Atomic Energy Authority. I'm the theme lead for remote handling. With remote handling, there's obviously a huge number of tasks that we can do in nuclear and nuclear decommissioning, but for the last 3 years we've been focusing primarily on Gloveboxes. A Glovebox is a way of managing the safety of your environment. So obviously in nuclear you're dealing with contaminants and nuclear materials that you wouldn't want your humans coming into contact with. And a Glovebox gives you a way to have humans interact with those while having a physical barrier.
So we are developing autonomous grasping systems using deep learning models to clear out cluttered areas. Here we have objects of many different shapes, sizes and textures, and the neural networks were trained with images of objects belonging to a completely different category. So these are completely new, novel objects that the system hasn't seen before. The robot moves to its initial position, and then it moves to different locations around the cluttered areas. And in each position, it uses the neural network and it updates a probability map. With that information, it finds the optimal grasping pose, and then the robot moves to that pose and picks up the object.
So hi, my name is Faiz. I'm a graduate mechatronics engineer, and I am a recent joinee to the RAIN group. And essentially what I'm doing with RAIN is I'm looking at one of the methods which we're using to control robots within the Glovebox. So the bit which I'm working on in particular is using what we call a sense glove, which is a kind of haptic device, and all it is a way of sending information from our hands to control what's going on in the robot, but also to actually receive feedback from what the robot is feeling. So say for example, if the robot were to pick something up or to hit a wall or something, that information is translated back to the user through the device. The device can do two things. It can give vibrations when it touches something, or it can give force feedback by locking the joints in position. So if the robot were to grab something and you are far away, what happens is that you'll feel the robot doing the exact same thing. So like you'll hit it and be like, oh, I can't grab any further. So therefore you don't actually damage the device, or you can actually have a better appreciation of what's going on within the Glovebox without actually being in there yourself.
Hi, my name is Ozan Tokatlı. I'm a researcher in the RAIN project. My interests are on robotics and human-robot interaction. So the Gloveboxes we're developing have robotic manipulators in them, and using a robotic manipulator in a confined space such as a Glovebox is not a trivial task. What I'm interested in is solving the inverse kinematics problem for the robots. The inverse kinematics is basically finding the joint values that our robots should have in order to do the motion we're looking for. I'm interested in the inverse kinematics problem, and my approach improves the inverse kinematics solutions by considering the singularities and the physical joint limits of the robot. So it's not just solving for the joint values for a given end effector configuration, but also we are looking at ways to keep the robot away from singularities and away from its joint limits. This approach is important for the operators because it gives them one less thing to consider during the operation. So they, instead of paying attention to what robot configuration is in and if it is singular or not, they have more time to focus on the task they're doing.
I'm Maddie. I'm a mechanical engineer working in the RAIN project, and I'm working on the tooling for the wiping and swabbing of the Glovebox. So what we're doing at the minute is rapid prototyping of different ideas. We've got 2 or 3 main ideas. One of them is a brush with Velcro on, so the robot can pick up the brush, stick to a wipe using Velcro, and then we can dispose of the wipe by pulling off the Velcro. And then the second one is a folding mop, which attaches, we've got an automatic shoe coverer, which attaches the wipe, and then the mop folds in half and the wipes drop off. At the minute, it's looking like the Velcro is more promising. The next thing we'll do is create an aluminium version of that, and then carry on the testing.
My name is Erwin Lopez. I'm a postdoc research associate at the University of Manchester, working for the RAIN project. So first, here in the RAIN project, we are working in Gloveboxes to try to replace humans and put robots inside. to make it safer. One of the tasks that are performed usually in Gloveboxes is radiation surveying, meaning that you have a sensor that records how much active surface is on an object. We're trying to work on solutions to do that robotically, so replace a person with a robot in an easy-to-use interface. We've done some experiments with expert operators where they have done it manually, and we record and understand how they do it, the timings, basically the strategies that they use. What we're trying to do with our interfaces, and as you see in the video with the Leap Motion hand tracker, is create an easy-to-use interface that is specially designed for this type of topics and this type of task. You only need to use your hand, you move it around, and the robot just follows your hand motion. So it makes it easier and possibly safer as we restrict the motion and we make it less aggressive and don't hit any of the borders. We're analyzing operators as they use any of these interfaces to understand which one is easier to use and how we can improve them in the future.